Hi, I'm Sagar. In this video, we will discuss classification of elements. Classification of elements. Linear and nonlinear elements, active and passive elements, unilateral and bilateral elements, time variant and time invariant elements, lumped and distributed elements. So we will discuss each classification in detail with its characteristics with some examples. Linear and nonlinear element. An element is said to be linear if for all time t its characteristics is a straight line passing through the origin, otherwise it is said to be a non-linear. Is said to be linear only if its characteristics a straight line passing through the origin. Now we'll check whether the given elements are linear or not. So if for example if we take any element, we want to find the relation of voltage and current across that element. So now this is the different characteristics of a elements. Now if you observe, so now it is a straight line passing through the origin. So now it is a linear element. Now if you see the graph here, it is also straight line passing through the origin. So now this element also a linear element. Now if you observe the characteristics of this element, so having two straight line. So now the characteristic is only a straight line, that too one straight line here, but it contains two straight line equation, so it is a non-linear. Now if you observe this, now this is a straight line but not passing through the origin. So this element is not satisfied that homogeneity property. So this also a non-linear because it's not passing through the origin. So anyway, it is a not straight line. Okay, the given element is non-linear. Now if we observe after this point, okay, the voltage is constant. It is independent on current. Irrespective of the current, the voltage is constant. So now it is not a linear element. Okay, it is not a straight line. Not after this, the voltage is constant. So now it is a non-linear. Now this element also, it is not a straight line. So now it is a non-linear. The second classification is active and passive elements. The element is said to be active if it delivers a net amount of energy to the circuit. Otherwise it is said to be passive. So if we take some examples. So for active, sources are the best examples and batteries. So for passive, resistor, inductor and capacitors. So it delivers a net amount of energy to the outside world, to the circuit, or else the element is passive. The resistor, inductor and capacitor are said to be passive if and only if the resistance greater than 0 and the capacitance greater than 0 and then inductance is greater than 0. So means it offers only positive values. Nothing but the slope is positive here. The slope is positive. If the slope is negative, then those elements are active elements. Now if you see the characteristics of some elements, now if you observe this, the slope is positive here, the slope is positive, the slope here, R is equal to V by I. V is positive, I is positive. So here V is negative and I is negative. We see minus V, minus I. Then here the slope is, we can say simply minus V by minus I. That is the slope, some positive value only. So now this element is passive. So now if you observe here also positive V and positive first coordinate both are positive, the slope is positive, the slope is positive. So the given element is passive element. Similarly, if you observe here, now see this is a plus V, this is a plus V and this is the minus I. Here simply the slope is negative here. The slope is negative. Here minus V and plus I. So here the slope is negative. The slope is negative. So now the given element is active element. Nothing but it is a source. Now if you observe this also here minus V and plus I. If you find the slope here, find the slope minus V by I. Here also the slope is negative. The slope is negative. So the given element is active element. And if we observe for this, okay, so here positive slope and here also minus V, minus I, minus V. So here also positive slope. So the slope is positive here. So the given element is passive element. So from these observations we can draw some conclusions. So now if slope is positive, now the element is passive, means that graph, okay, in first coordinate and in third coordinate, then that element is positive. If the graph is in second and fourth coordinate, then that element is active element because the slope is negative here. The slope is negative. If we observe this graph, okay, so now the graph is in second and fourth coordinate. So now the slope is negative, that element is active. So by seeing this graph, we can say the given element is active or passive. So the next classification is unilateral and bilateral elements. An element is said to be bilateral if it offers the same impedance for the different directions of the same current flow. Otherwise, it is a unilateral. So same impedance for the different directions of the same current flow. Now let us consider a simple example here. Now I'll take one element Z. One element is Z here. So then now for a given current I1, so the voltage across the element is the V1. The impedance then Z is equal to V1 by I1. If I'll take a same element, okay, same Z, same element, but the current is in opposite direction. Now the current is like this. Now this is the I1 in opposite direction. The voltage across that element is V1. Now impedance here also V1 by I1 will get the same impedance. Even though if I change the current direction, the impedance, it offers the same impedance. Now that element is called bilateral. Otherwise, the element is unilateral. Now we will see. So we will observe these graphs and we will find whether the given element is bilateral or unilateral. So before that, I will give a best example. So examples. So if it is bilateral, so the best examples are resistor, inductors and capacitors. For unilateral, the examples for diodes, because in forward bias it allows the current will get some impedance, but in the reverse bias, if the current is in opposite direction, it offers high impedance in the reverse bias in terms of mega ohms. Now if you see the diode characteristics, now in forward bias like this, but in reverse bias the current is 0. This I, the current is 0. It offers in terms of mega ohms in reverse bias, but in forward bias in terms of ohms. So the best example for unilateral is a diode. Now we'll see all graphs and we'll find now. So now see here, if you find the slope, here, so positive here. So now, but if the current is negative, if the current is negative, but it offers same positive voltage only, so we'll get different impedance. So now this element is unilateral. Clear? Now if you observe this element, okay, it offers. Now if you see, assume here this is the V1, this is the I1. Similarly, this is a minus I1 and minus V1. The impedance here, the slope is V1 by I1, will get same, okay, some impedance, some constant value like assume right Z1. Here also minus V1 by minus I1 will get Z1 only. So even though we'll get a negative current, okay, the impedance is same. So now this element is bilateral. Now if you observe this one, now it offers same impedance. Here. Now here this I1 V1, this is also like I1 V1. So both are positive. So Z1 is equal to V1 by I1. Here also Z1 is equal to minus V1 by minus I1. So both are same. Even though current is negative in opposite direction, it offers the same impedance. Now here also at this point also same. But if you observe this graph, now if you observe this graph, now here for example this is a 2 amps, this is like 4 volts. Clear? So but the current here, this is a 2 amps, this is a 1 amp. So at 2 amps, what is the voltage here? 2 volts. Now if you see here, so 4 volts by 2 amps, here we will get 2 ohms. But in this coordinate, if you observe, the current is 2 amps, the voltage is 2 volts. So minus 2 volts by minus 2 amps. The impedance is 1 ohm. So for different currents, okay, here 2 amps, here minus 2 amps. For different currents, opposite current, but the current is same. The current is in different direction. It offers different impedance. So now this element is unilateral. This element is unilateral. Now if you observe this, it offers same impedance. Okay, it offers same impedance. So plus V1, I1, so minus I1, minus V1. It offers same impedance. So now this element is bilateral. Now this also offers same impedance. Clear? So now here V1 minus I1 will get here the impedance is Z1 is equal minus V1 by I1. Similarly here the impedance is, so Z is equal to V1 by minus I1, will get a same value. So now this element also bilateral. So we observed one thing. So every linear, this is the linear element. Yes or no? This is the linear element and this is also linear element. So nothing but here we observed one note here. Every linear element is a bilateral element. Every linear element is a bilateral element, but vice versa is not. Okay, but not every bilateral element is a linear element. That converse is not true here. The next classification is time variant and time invariant. An element is said to be a time invariant if its characteristics does not change with the time. Otherwise, it's said to be time variant. Now, its characteristics does not change with the time. Now, for example, even if I take, okay, these are the graph at t1, at t is equal to t1. The same experiment if I do, then I'll get a different characteristics at different timestamp. If t is equal to t2, if t is equal to t2, if I get a graph like this for the same element, so the characteristics depends upon time. The characteristics are changing with respect to time. Then that element is called time variance. So now this is the time varying element characteristics. But in case of time invariant will get a, so now in case of time invariant, for all time t, for any time will get a same characteristics. Will get a same characteristic for any time t. For any time t will get same graph, same characteristics. Then that element said to be time invariant. So example here, that examples are resistor, inductor and capacitors are time invariant elements. Time invariant elements. So lumped elements means lumped elements can be separated from the circuit, whereas the distributed elements cannot be separated from the circuits. In case of lumped elements, the voltage and current are a function of time alone, whereas in case of distributed, the voltage and current in a distributed elements are function of space and time. Yes, if for example, the resistor, inductor, capacitor, these are the individual components like a diode, transistors are the examples for lumped. So whereas in like inductance, resistance, capacitance of the transmission lines, those are the distributed elements. There we can find the resistance 2 ohms per meter, not only 2 ohms, like per meter. Along the length we'll find the value of the parameters. So this is a very simple classification. So simply we can say that size of the lumped element is smaller, okay, whereas the size of distributed element is comparable to the wavelength of applied voltage and a current. So that lumped element which is concentrated at a single point or place, whereas the distributed element distributed all along the circuit. So simple example is a transmission line for distributed, whereas in lumped, simple resistor or inductor. Thank you. So by this we'll complete classification of elements. So we'll solve some numerical problems on the classification of elements. So find the nature of the element. So they provided one simple element. They provided the relation between the voltage and current across this element. Then we need to find so which type of element it is. Now if you see this graph, now it is not a straight line, not passing through the origin. If it is linear, then it should be a straight line, the two passing through the origin. So it is a non-linear, and also it offers same impedance. It offers same impedance even though current is negative. Even though current is negative, it offers same impedance because it is like mirror image. Clear? So now it is a bilateral, and that slope is positive. The slope is positive, nothing but first and third coordinate. Now it is a passive. Then if we observe this graph, then simply it is a straight line passing to the origin. So now this element is a linear element, and then here slope is negative. So V1 here minus I1. Simply, so here the slope is negative. So if slope is negative, then it is the active elements. Simply second and the fourth coordinate, it is an active elements. Now it offers same impedance, even though if we change the current, okay, now current is minus I, offers some impedance Z1. The current is plus I, so it offers same. So here this I1, sorry, okay, this I1, this minus V1, it offers same here. So V1 by minus I1, here minus V1 by I1 will get same impedance, even though the current is in different direction. So now it is bilateral. Similarly, if you see, it is a non-linear because it is not a straight line, okay, it is a non-linear. And now if you observe, so this side V is positive, I is positive, the slope is positive, but if you observe this side V is positive, this is a V1, this is a minus I1, minus I1. So the slope is negative this side, the slope is negative. If it is slope is negative, then this is the active element. And also it doesn't offer same impedance even if we change the current. For negative current, now the impedance is V1 by minus I1. But positive current, the impedance is like here V1 by I1. But for negative current, minus V1 by I1. V is positive only. So now this is the unilateral element. So anyway, it is a straight line passing through the origin. So it is a linear element. Clear? The slope is positive here. The slope is positive. So now it is a passive element. It offers same impedance even the current is negative. Clear? Same impedance. So now it is a bilateral element. Similarly, it is a non-linear. Simply it is a non-linear. Now here this is a minus V and this is a positive. Even here slope is positive, but for this the slope is negative. Clear? So minus V1 and plus I1. Minus V1 plus I1. The slope is negative. If slope is negative, then that element is active element. You may ask, okay, sir, here the slope is positive. If slope is negative, definitely that element is active. I will explain in the further classes how that source, okay, offers negative impedance as well as the positive impedance. So now this is the active elements. Now it offers different impedances because if I is negative, okay, there is no, so if I is positive, if I is negative, minus I, the voltage is 0. Yes sir. So now it is a unilateral element only. Unilateral. Now if you observe, it is a straight line but not for all time t. Okay. For now, actually we should draw like this. Okay. This is correct. Now if you see, it is not a straight line for all time t. Clear? It is not a straight line for all time t. Clear? So now it is a non-linear only. Clear? And then slope is positive. Okay, the slope is positive. V1 by I1, the slope is positive. So now it is a passive element. And for negative currents, okay, if the current is in opposite direction, the voltage is 0. It won't offer same impedance for other current direction. So now this element is unilateral. I hope you understand the basic classification of elements. So the elements are classified into 5 types: linear and non-linear. Nothing but if that characteristics is a straight line passing through the origin. If it is active and passive, the slope is positive. R, L and C are greater than or equal to 0. Those are the passive element. Or else the negative. Means if the graph is in first and third coordinate, if the slope is positive, those are the passive element. Or else the elements are active. Means the slope is negative. And unilateral and bilateral. So that element should offer the same impedance for the same current in opposite direction. Or else this element is said to be unilateral. If bilateral means it offers the same impedance. So, and time variant and time invariant. So, for all time t, so irrespective of time, it offers like the graph is should be same. The characteristics does not change with respect to time. It is independent on time. So it shows the same relation if I do I experiment at different timestamps. So now that element is called time invariant element, or else we can say time variant element. So lumped and distributed. So now in our network theory in electrical circuits, all are lumped circuit only. It contains a discrete component like inductor, resistor and capacitor individually. We can separate those elements from the circuit. So distributed nothing but like example of transmission lines where that all parameters distributed along the wire. So thank you. I hope you cleared this classification. So if you have any doubt, please comment in the comment section. So I will try to help you to find the solution.